All right, you're ready to do your lab report. So let's work through what you're going to have to do on that lab report. So for our forces lab, we found the mass of our unknown group of things. And so what do we got to do first is we got to find our percent error. So we calculate our percent error. If it's greater than 10%, you're going to have to redo the lab. Okay, so you're going to have to go back, get another piece of paper, remeasure your angles, do it again. If you're in the range of 7 to 10%, this is kind of a gray area. So I'm going to let you make the choice if you're going to continue or if you're going to maybe remeasure those angles. Make sure that those lines were horizontal. Kind of double check some of that stuff, okay? Less than 70%, we're good. We're moving on, okay? So once we get to that less than 7% number and we're good, we're moving on, we're going to use the over-under method to analyze what kind of uncertainty we had in our original measurements and that percent error that we ended with. So how to do the over-under method, the first thing you need to do is estimate and justify uncertainties in your angles. So for instance, here I have my protractor up. I'm looking at here and I see, I think it's 9 degrees. But it could be 9.5. It might even be as high up as 10. So I'm going to say it's 9 degrees plus or minus 1 degree using this protractor right here, okay? And maybe if I'm making those lines underneath, maybe those lines maybe add another, half a degree. So you're going to have to look at your paper, look at how you're using your protractor, and justify any uncertainty in your angle, okay? Now with that uncertainty in your angle, you're going to do the over-under method and find a high and a low mass. Okay, so let's talk about how to do that over-under method. So here we go. So I have a plus or minus 1 degree was my example here. Yours will probably be more accurate than that because of your protractor you're using. But if this was just a little bit heavier, let's see what happens to those angles. So as I pull this down, you'll notice that this angle gets bigger. And how I know it gets bigger is if this string gets more vertical, that angle's getting bigger. If the string gets more horizontal like this one, that angle's getting smaller. So my larger unknown, I'm going to have to add to this angle, subtract from that angle, subtract from that angle, and that other line over there, it's getting a little more horizontal. So that's going to be another subtraction. So I'm going to go through, add, subtract, subtract, subtract to get my higher mass. And then I'll do the exact opposite to get my low. So this would be less, so I'd do something like this, and so I would subtract, add, add, add. That's going to get me 2 masses, a high and a low value. I'm going to use those to figure out what is the uncertainty in my mass. So what we're doing is we're translating from our uncertainty in our angle that we estimated and justified of 1 degree here in my example to an uncertainty in my mass I calculated. All right, so to do that, we take our high mass, subtract it from our low mass, and divide by 2. This gives us our uncertainty in our mass, sigma. Okay? And so I could write that as, maybe it was 37.3 grams plus or minus 0.8 grams. Okay, something along those lines. Now that I have my uncertainty, which is this plus or minus number here, I'm going to look for my difference from my expected value, and I want to put it in terms of sigma, not in terms of grams. So I kind of want to change the units. So when we have acceleration, we might find the acceleration in g's. This is kind of the same idea here. So we're going to take our calculated value minus our accepted value, kind of the top part here, and we're going to take the absolute value and divide by sigma. So this is going to transform it from a difference in grams to a difference in sigmas. Now, what does this mean for us? What does this help us do? Well, if your difference in sigmas is less than 1 sigma, that means the uncertainty in your angle is the likely source of your error. Okay? That means you did a good job completing the lab. The uncertainty is the reason you have error. And that's what you want to write down in your conclusion. If you're in the 1 to 3 sigma range, there might be other small sources of error, or your uncertainty was too low, meaning you said you were really exact and maybe you weren't. And then lastly, if you're greater than 3 sigmas, there's another source of error present in your lab. So this is kind of that conclusion. So we'll use the over-under method to find your difference in sigmas, and hopefully we land in this range here. And we can describe that in our conclusion. Again, get that turned in early for feedback so then you can make corrections and turn it back in before the due date.